Hi, it's Jim from maverickstar Observatory. Very warm welcome to you and good afternoon. Guys, we've got quite a bit of work ahead of us today. I'm just getting through it now, so a bit later on we'll have a look at the latest magnetic North Pole. As you know, it's the 17th of the month. Before we start getting into the data, I want to say a huge thank you to our superstars. We've got a recent one that's just come online. I'm going to be showing you the data from Colombia, just test data at the moment. It's gotten back into full use now, so it will be collecting data for another month, and then Michael over there will send it to us. But we're looking at the data from Canada. As you can see, it's just a couple of days. That's because our superstar Kendall is off on a little trip. He's assured me though when he gets back, as soon as he does, he'll forward us probably just over a little over a week's worth of data. But he said he'd send us these few days just so we could see a strange anomaly just towards the end of the right hand side of the chart, where it dips nearly 2 microteslas, and it's distinct because it's separated by hours and it dips the same. So we'll keep our eye on that. You know, we can see over time, you know, the intensity over Canada dropping off. But I want to now get over to show you some data from Colombia. It's our first batch of data. Again, it's only 24 hours or thereabouts worth, but nevertheless we're up and running. Things are looking sweet over there, and I'm really interested to have a look at what's going on in Brazil. And in a couple of months, I'll have finished another muon detector, and we can send that over and measure the magnetic intensity and the amount of muons that are streaming down in that very low intensity which Colombia covers. So we'll be looking at that in months to come, and I'm hoping to see a dramatic change in this region, because as you guys know, and I'll show you on the map just in a short while, just after we've had a look at the data, that this is one of the regions known as the the Safe Atlantic Anomaly. It is known for being sort of a magnetic hole on the Earth, and even affects some spacecraft as they fly over it. So, you know, we should be seeing a lot more radiation in that region, and, you know, in a couple of months' time, we'll not be just looking at the magnetic intensities playing out in that region. We'll also be looking at, hopefully, the radiation with regards to muons, because we'll have one of those detectors out there. So we're doing quite well, guys. You know, we're back up to 4 magnetometers in the field, 1 in Perth, 1 in Arizona, 1 now in Colombia, 1 in Canada. I really don't hold hopes out for ever securing 1 in Russia, but it won't stop me trying, because as we know, as Canada's intensity drops off, Russia's is picking up, and that is why the pole has begun to migrate since the 1900s. And as the intensity has increased and the intensity over Canada has weakened, it has drawn that magnetic North Pole further over the northern hemisphere much quicker, covering more distance in less time. So let's go and have a look at the Colombia data. So here we are. Huge thanks to Michael, one of our new superstars now, who has painstakingly kept with it over the last couple of weeks. I mean, we had a little bit of trouble in customs, a bit of money had to be paid, then we had to set up the power supply, because obviously I'd sent a European adapter to power it, and of course I suppose it's one of those continental plugs that are in Colombia, and that had to be sorted out. Then we had a little problem with the SD card, but we've finally got there, and the data looks like it's coming off the magnetometer as we would expect. No erratic and sporadic movements on the microteslas. So, you know, absolutely fantastic work. Great for you hanging in there, Michael, with us, and I'm sure we'll all thank you for joining us. And, you know, now we can all look forward to some data in a very unusual part of the world. So let's go and have a look on the map where this intensity is that we're talking about. So we're looking at the magnetic intensity map here. You can see over Canada, Russia, and just coming up on the Safe Peninsula of Australia, there are large magnetic intensities. The largest one, or the strongest one, measuring somewhat 60,000 nanoteslas, is over Russia. But one of our weakest intensities is that blue region there. And we have our magnetometer just on the fringe, or just inside that blue region, where it just begins to get darker. Now, we know the South Atlantic anomaly is expanding, and we know that it is slowly breaking into two, one part going over South Africa, the other and the most lowest intensity staying somewhere over Chile or Brazil. So it is really interesting from this point on out what we are going to find in the weeks and months to come with the observation now that we are making in Colombia. So, you know, guys, we've got, you know, 4 out of the 5 regions on the planet covered with one of our magnetometers. We have 3 muon detectors out there, one here in the UK, one in Canada, one in Australia. We will be having one shortly over in Colombia in a couple of months, and we can monitor not just the intensity of the magnetic fields around different various parts of the world, but we can also calculate the radiation with our muon detectors. And the nice thing about these is there is no SD cards involved. It just you know, puts the information on the screen over time. So long as the muon detector's got power, it will just keep clocking up over that period of time, measuring per square meter per second, and how many muons fall in that period of time. So we've got it covered. You know, we are moving forward. If we could just get that last one in over Russia, or very close to Russia, maybe North China, that probably would be good enough. We could see some activity going on there, but you know, we can't complain with where we are. We've done an absolute amazing job. So I know what your guys have come here for, because it is the 17th. First of all, I want to say, you know what, guys, we couldn't have done any of this if it weren't for people like Jim, JBM, and a lot of others that continuously support what we do here at the observatory. And there is a link down there if you want to help us continue this, because let's face it, you're going to see how close we are to that theoretical 40-degree mark in the next slide. And you know, we're talking 7 months away from surpassing that point. We are now just leaving the North Atlantic ridge. We've crossed it, and remember, when we went over that, or we started to go into this region, for some reason the magnetic pole started to accelerate very slightly, you know, covering 5.1, 5.2 miles on average every month. Is that a coincidence that as we pass one of the most natural cracks in the crust along the North Mid-Atlantic ridge, that we get an acceleration of the magnetic North Pole? Well, it remains to be seen, because now we are just about to leave that territory, crossing that ridge, and we are at that same time 7 months away from that theoretical 40-degree mark, where I suggested that, you know, based on some experiments, what we should be seeing around the 40-degree mark is an acceleration, because what will be happening at that point is the magnetic North Pole will be leaving its anchor, which slows it down in the migration process, and it should go into leave the strong field lines and move into the weak field lines. And as the experiment showed, things don't hang around in those weak field lines. We're very close to that. It would be nice to get, you know, well, I dare say we will be ready with a muon detector in Brazil. Sorry, not in Brazil, in Colombia. If anything happens, we're going to pick it up. Likewise in Canada, likewise here in the UK, and likewise down there in Perth, Australia. So, you know, it's very exciting times. I know it's a little bit odd to say when, you know, the repercussions of what are taking place on our Earth have caused a lot of disaster and displaced literally hundreds and hundreds of millions of people. You know, when you think about it, it's very serious. And like I've said before, we're not even at the equilibrium point yet. So, you know, let's see where the Earth's magnetic field North Pole is at this current point, and how many miles it has covered. And as always, I'll give you the GPS coordinates, the long and latitude, so that you can track it yourself on your own Google Maps. Let's get on with it. Just before we get on to the location of the magnetic North Pole currently, I just want to bring this to your attention. Look, we're at the beginning of the year in January here. You can see the line is very straight. Same for February, but watch what happens. See that line is becoming more wavy as the months go on. To the current one that I uploaded this afternoon, you'll see that the line is becoming more unstable as the months go on. It could be another indication that something is close to be taking part. Maybe with that 7-month limit that's on there. We might be getting closer to reaching that point, and this could be the first signs of that. Kendall has noticed a slight decrease over the intensity over Canada right now. I've just showed you 9 months of magnetosphere data. You can see that the line becomes more unstable as the months go on. If this is a trend, we could see further destabilisation, and it would make me feel a little bit more confident about that theoretical 40-degree mark. A quick look at the TriMag data before we go. I'll put that up as well for us today. You can see I've obviously had a lot of work to do. I had to build the links for candidate data to go up, but we can still see a lot of 13.5s coming off the magnetometer, more so than ever, and it should come as no surprise that we're not going to see so much of a change in the amount of migration that the magnetic North Pole has migrated and the speed. And with saying that, let's go over to Google Earth and give you those longitude and latitudes. So, like I suggested, it's no surprise that we are still travelling at the same speed over the same amount of distance, whilst just about to leave the North Atlantic Ridge, which I'll show in a minute when we back it out. But for those that are interested in putting the pin marks on their own Google Maps, the latitude is 82 degrees by 11 hours 56 minutes 26 seconds north. Longitude 117 degrees by 12 hours 40 minutes 23 seconds east. And you can see just there in the fate ruler line that we've moved 5.1 miles. So no real change. It fluctuates between 5.1, 5.2 every month, but there's not a great deal of difference in it, to be honest. We're still very close to hitting that 40-degree region within the next 7 months, and God knows what we will see happen at that point. Maybe nothing, maybe it could be shocking. We'll just have to wait and see. And I've said this time and time again, it doesn't really matter. The thing is that I've put something on the table that is feasible, and no one can take that away. It is absolutely possible, but scientists don't know to this very day what it is that generates the magneto in our Earth. For that reason, no one could say whether I was right or wrong. The only thing that will prove that is time, and it still won't put me off this research that we do here at the observatory tracking the magnetic North Pole, because if it doesn't do anything at that point, it doesn't mean much at all. It just means that what we thought and suggested was responsible for the generation of the magneto, which creates the magnetosphere and the dipoles on our planet, it just means that wasn't what it was. But nevertheless, if something does happen or it doesn't happen, it doesn't make any difference, because we gain information out of it either way. So very exciting times, I feel, right now. We do know a lot. We do know what's responsible for modifying the jet streams on our planet. When countries like Afghanistan gets even in the monsoon season 1,000-year record rainfalls, it's very likely because of the interchange now between the two subtropical jet streams over the northern and southern hemisphere merging and delivering a double load of water. You won't hear no meteorologists talking about this, or climatologists. I don't think a lot of them have put it together yet, or if they have, they're certainly not speaking publicly about it. And if they're not doing that, why aren't they doing that? If they're scientists, they have a duty to humankind to reveal their findings, not keep it to themselves selfishly. You know, we're all adults. If there's something on the horizon, I'm sure you, like me, want to know what it is, so that we can make some formal preparations for it. Guys, that's the Poleshift news update for the 17th of this month. You know, there's a link down there if you want to help support us. You know, I really hope that you do. You know, when we're putting these magnetometers, muons together, you know, especially with the muon detectors, one of those chips in there is £120. Probably gone up now because I haven't brought one for a few months. With like everything else that's going up, they're not cheap. But let's put it this way: if it costs me £300 and my time to build it, it's still better than paying £8,000 for, you know, a factory built one. It does the exact same job. Like I say, you know, with a big thanks to MIT in the United States, you know, we are able to build them muon detectors. It took 2 years just to program and build the electronics for the TriMag system that we've got. We've got one of the only pieces of equipment in the world that measures and tracks the magnetic North Pole very accurately. And if you look on the TriMag data, you'll see, you know, to get an accurate prediction of where the magnetic North Pole is at its current position, you know, we have to collect some 300,000 plus data sets. So you can imagine there's a lot of you know, computing going on with regards to you know, revealing the actual position. You know, it's not an easy task, and that's one of the reasons why it took 2 years to program it. You know, likewise with the magnetometers, they come a little bit easier because I'd got a bit better at writing the programs, and some of the program from the TriMag was able to be lent to the magnetometers. And then, you know, we have built other equipment as well here. Our own oxygen sensors using state-of-the-art Illuminox sensors, you know, the same sensors that the military use in their aircraft. So, you know, we've done really well, but the only way we have got this far is by people supporting what we do. You know, this really is one of the most important days of the month for us here at the observatory. It'd be great to see a few people stand up to the line and chip in, you know, do their little bit. And you know, I'm going to leave you with that, guys. The links are down there. You know, the Patreon, if you want to become one of our patrons, you can. The link is there. If you want to just make a one-off payment, you know, you can do so on the PayPal link down there. But the main thing is that you don't take any of this for granted. You know, these are serious times that we're living in, and this anomaly is rare, probably for a reason. You know, last time the Earth went through a magnetic reversal, 780,000 years ago. It had sent, our Earth has gone through more interglacials than it has magnetic reversals, completed reversals. So that gives you an idea of, you know, the extent of this anomaly. Anyhow, guys, you know, it wouldn't be a bad idea if you started prepping and making some plans for emergencies, contingency plans for your family, because we are approaching possibly a time where things could get a lot more worse for a lot more people on this planet. And it was only a few weeks ago I showed you what was happening in Afghanistan, and I told you 33 million people displaced. You know, the situation's got a lot worse there for a lot of people. We're talking cholera, dysentery, a lot of other common diseases, polio, that turn up when the waters go stagnant. But they've also got the fact that they are looking for food right now, and they have lost a lot of crops, so that without energy, they don't have clean water, they don't have food. And you know, they thought 2 months ago something like this could never happen to them, and that's the way most of us sadly think. You know, we're here to try and give you a heads up, get you show you evidence that something is taking place, and it's not like it's not a light anomaly. You know, something you can just shrug your shoulders with. You know, I don't like pulling the duvet off you when you're nice and snuggled in bed and you're warm with your families, but I want to tell you that, you know, this event shouldn't be taken lightly. Regardless, it should not be taken lightly. I've got something hopefully I can show you in the next few days with great interest. It's based on 10-year records. And it, you know, most of the data comes from big organisations, and it begs the question: what is exactly wrong with these organisations when they are still beating a drum which clearly shouldn't be beaten anymore. You know, I think the writing's on the wall. I think 10 years is a good distance of time to get, you know, an idea of what is happening, even if we only make short-term predictions on that. But I'll leave that as a bit of a cliffhanger for you, and I'll get on with just saying, you know, guys, you have an amazing day. Links down there, as always. Bye for now.